An engineer at Megacorp has an IAM policy that clearly allows KMZ encrypt. The permission is right there in black and white, and yet the request comes back denied. Nothing is wrong with our identity policy. Something else entirely is standing in the way, and it lives on the key itself. You're in the right place. This is Cloud Architect Path. By the end of this video, you'll know when to reach for a KMS customer managed key, when a compliance mandate actually forces you to CloudHSM, and why a valid IAM permission can still be blocked at the key. This sits inside the Design Secure Architectures domain, the most heavily weighted part of the Solutions Architect Associate exam. Let's anchor to what we've already built. In earlier episodes, IAM decided who a principal is and which actions they're allowed to call. We saw that resource-based policies attach directly to a resource and name a principal explicitly. And underpinning all of it, the default deny rule, nothing is permitted unless an explicit allow says so. Hold on to that resource-based policy idea because KMS takes it somewhere surprising. Before we dig in, let's pin down 5 terms you'll hear throughout. Envelope encryption is encrypting your data with a data key, and then encrypting that data key under a bigger key. The data key is the symmetric key that actually touches your data, then gets discarded. The KMS root key is the top-level key that stays locked inside hardware and only ever encrypts data keys. A key policy is the resource policy attached to a KMS key, and it's the primary authority over who can use that key. And CloudHSM is a dedicated single-tenant hardware module that gives you sole custody of your keys. So here's the situation Megacorp is in. A GDPR audit flagged that EU customer PII was sitting in S3 with no encryption at rest. That's problem 1. Then their SO2 obligations pile on problem 2. They need demonstrable auditable control over the encryption keys. Notice these are 2 distinct jobs. You have to encrypt the data, and separately, you have to prove who controls the keys that protect it. Amazon Web Services answers both with 3 services: KMS, CloudHSM, and ACM. The rest of this video is about picking the right one. Here's a constraint that shapes everything. KMS can only directly encrypt a payload up to 4 kilobytes. That's it. So how does KMS protect a multi-gigabyte S3 object or a whole UBS volume? It can't, at least not directly. That single limit is the reason the entire envelope encryption pattern exists. And it's why every integrated service quietly does the same dance under the hood. Picture a locked safe deposit box. You lock your bulky documents inside the box with a small brass key. That brass key is your data key. Now, instead of carrying that little key around, you seal it inside a tiny envelope and drop the envelope in the bank vault. The bank vault is KMS. Because the box is locked, you can carry it anywhere you like, and the sealed envelope rides right alongside it. Anyone who wants into the box has to go to the bank first and ask them to open the envelope holding the key. The bulky data never goes to the bank. Only the tiny key does. Let's watch the pieces come together. At the top left is the KMS root key. It lives inside the hardware security module and never leaves it unencrypted. When you need to encrypt something, KMS runs generate data key and hands back 2 things at once. The first is a plain text data key. Your service uses that to encrypt the actual object locally, then wipes it from memory. The second is an encrypted copy of that same data key. That encrypted copy is safe to keep around. So at the bottom, both pieces get stored together, your ciphertext and the encrypted data key sitting right beside it. The data key you need to unlock it is useless without a callback to KMS. The KMS developer guide states it plainly. Envelope encryption is encrypting your plain text with a data key, and then encrypting that data key under another key. And critically, the root key stored in KMS Never leave the FIPS 143 security level 3 validated hardware modules unencrypted. That last part matters. Because the root key never leaves the hardware, even if someone compromises your application, all they get is the encrypted data key, which is worthless without a KMS call. Let's contrast the two keys directly, because keeping them straight is the whole game. On the left, the root key. It lives inside the FIPS validated hardware modules, never leaves them unencrypted, and it only ever encrypts data keys. Every single use of it shows up in CloudTrail, because you can't touch it without calling the API. On the right, the data key. KMS generates it on demand. It does the bulk encryption locally on your data, and the plaintext copy gets discarded the moment it's done. KMS never stores it and never manages it. Think of the root key as the master stamp do not duplicate that stays in a locksmith's shop, and the data keys as disposable working copies the locksmith cuts on demand. Now let's make it concrete with a real S3 upload using server-side encryption with KMS. First, S3 calls generate data key and gets back that plaintext plus encrypted pair. Next, it encrypts your object locally with the plaintext key. Then it discards the plaintext key, wiping it from memory. After that, it stores the encrypted data key as metadata, right beside the object. And later, when someone reads the object, S3 calls KMS decrypt to unwrap that stored data key so it can decrypt your data. Notice the upload path touched two different KMS actions. Remember that? Because it's about to bite someone. Here's the mistake people hit constantly. To upload to a KMS encrypted bucket, your principal needs KMS generate data key. Granting only KMS decrypt feels like enough, but it isn't, and the upload fails with access denied. The fastest way to diagnose it is CloudTrail, which shows you exactly which action was denied. When you see a mysterious upload failure on an encrypted bucket, the missing generate data key permission is the first thing to check. Quick recap before we move on. KMS caps direct encryption at 4 kilobytes, so instead, it wraps a small data key. That data key encrypts your object locally, and KMS only ever touches the small key. The root key never leaves the hardware module, which is exactly why every use of it lands in CloudTrail. And here's the permission split people get wrong. The simple upload to an encrypted bucket needs generate data key because you're minting a fresh data key. Downloading that object later needs decrypt because you have to unwrap the key first. That's the mental model. Now let's talk about who owns these keys. KMS gives you 3 kinds of key, and we'll take them one at a time. There's the Amazon Web Services owned key, a shared pool of keys living outside your account that you never see and can't audit. There's the Amazon Web Services managed key, which lives in your account but is created and controlled by the service itself. And there's the customer managed key, which you own outright. The policy, the rotation, all of it. The way to hold these in your head is as a spectrum. As you move across it, you gain more control, but you also take on more responsibility. Think of it like where you keep your valuables. And Amazon Web Services owned key is a hotel safe. It's there, it works, but you never see it and you can't inspect it. An Amazon Web Services managed key is a bank deposit box in your name. You can look at it and see its history, but the bank sets the schedule for changing the lock. And a customer managed key is a safe you install in your own home. You choose the lock, you choose when the combination changes, and you decide who gets a copy. Same valuables, very different levels of control. Here's the spectrum laid out. On the far left, the Amazon Web Services owned key. Invisible, no CloudTrail visibility, no rotation control, and it carries no monthly key fee. In the middle, the Amazon Web Services managed key. Now it's visible and it does show up in CloudTrail, rotates automatically once a year, but you still can't touch its policy. And it also has no monthly key fee. On the right, the customer managed key, full policy control, rotation you configure yourself, and a complete CloudTrail audit trail for about $1 a month. And that leads to the rule at the bottom. The moment you need control or audit, the customer managed key is your default. So here's your decision rule, and it's a clean one. If a scenario asks for custom key policies, control over rotation, or an audit trail of key usage, the answer is a customer managed key. Those three requirements map directly onto exactly what SOC 2 and GDPR key control obligations demand. When the scenario emphasizes control or auditability, you reach for customer managed and you don't look back. So what does Megacorp actually do? They turn on S3 default encryption using server-side encryption with KMS, backed by a customer-managed key. Envelope encryption now protects the PII at rest, which clears the GDPR flag. And because every use of that key is logged, CloudTrail becomes the paper trail that proves control for SOC2. Notice what they didn't need. No CloudHSM, no dedicated hardware, no $1,000 bill. Just a customer-managed key for about $1 a month. That's the default answer for the overwhelming majority of scenarios. Now we can finally answer the puzzle from the opening. The KMS key policy is its own authorization gate, completely separate from IAM. This is the part that catches people because it works differently from every other resource policy you've seen. Having IAM permission to a service does not, by itself, get you through the key policy. There are two doors here, and both of them have to say yes. Think of it this way. Your IAM policy is the building key card that gets you into the office. The KMS key policy is a separate locked vault room inside that office, and the vault keeps its own guest list. Even with a perfectly valid key card, if your name isn't also on the vault's list, you don't get in. And there's a second twist. The vault has to have agreed to honor key cards at all. If it hasn't, your IAM key card means nothing to it. That's precisely why an engineer can have full IAM permission to decrypt and still get denied. Amazon Web Services is blunt about this. Unlike other resource policies, a KMS key policy does not automatically give permission to the account or any of its identities. And it goes further. No principal, including the account root user or even the person who created the key, has any permissions unless they're explicitly allowed in a key policy, an IAM policy, or a grant. Read that again? Not even root gets a free pass here. The key policy is the primary authority, and it starts by trusting no one. So how do IAM policies ever work on a KMS key? Through one specific statement in the default key policy called Enable IAM User Permissions. That statement is the vault agreeing to honor key cards. It delegates authorization to IAM, which lets your account use ordinary IAM policies to control the key. And here's the sharp edge. If you remove that statement, IAM policies granting KMS access simply stop working for that key. From that point on, only principals named directly in the key policy or through a grant retain access. Delete the wrong thing, and you can lock yourself out of your own key entirely. Let's see the two-gate rule bite in a cross-account setup. Remember, Megacorp runs a lockdown production account and a separate sandbox, where developers need access to selected production resources. A role in the sandbox account tries to upload PII into a KMS encrypted production bucket, and it fails with access denied on generate data key. Look at the checks. The IAM policy in the sandbox account allows KMS just fine, but the key policy over in the production account never named that role, so it fails there. The fix is to grant the role in both places, the key policy in one account and the IAM policy in the other. Update only one side, and it silently keeps failing. And one more note, the Amazon Web Services managed AWS/S3 key can't be used for cross-account uploads at all, which is another reason customer-managed keys win here. Let's lock in the middle of the video. 3 key types sit on a control spectrum, and customer-managed is your default whenever control matters. The key policy is a separate authorization gate, so IAM permission alone can still come back denied. The enable IAM user permissions statement is the one thing linking KMS back to IAM, and cross-account access has to be granted on both sides, never just one. Now let's talk about keeping those keys fresh. Symmetric customer-managed keys can rotate their material automatically on a schedule. The default is 365 days, and you can configure it anywhere from 90 days out to 7 years. Here's the elegant part. When rotation happens, the key ID and the ARN stay exactly the same. Nothing in your application references breaks, because from the outside, it's still the same key. And KMS keeps all the old material around, so anything you encrypted before the rotation still decrypts fine. But be careful about what rotation actually does. It does not re-encrypt your existing data, and it does not replace the data keys you've already generated. So if a specific data key were compromised, rotating the root key would not fix that. In fact, Amazon Web Services' own guidance is that you shouldn't rotate KMS keys unless a regulation requires it, because the design already mitigates most of the risk rotation is meant to address. Rotation is a compliance checkbox more than a security upgrade. There's an important fork here, depending on where the key material came from. On the left, keys with Amazon Web Services generated material. They support automatic rotation, they keep the same ARN across rotations, and Amazon Web Services owns the durability of the material. You only need to bother rotating them if compliance demands it. On the right, imported material, sometimes called bring your own key. Automatic rotation is permanently off the table because Amazon Web Services doesn't control that material. You can only rotate it manually or on demand, and you own its durability entirely. If your imported material expires or gets deleted, the key becomes unusable, and there's no getting it back. The documentation draws the line cleanly. You cannot enable automatic key rotation for a KMS key with imported key material, but you can rotate it manually. So when you're working with imported or external key material, remember that automatic rotation just isn't available. That pairing of imported material and manual-only rotation is the distinction to keep in your back pocket. Now let's meet the heavyweight option, CloudHSM. This is a dedicated single-tenant hardware security module. The hardware is yours alone, and you hold sole custody of the keys. It's validated at FIPS 143 Level 3. It exposes two programming interfaces, the PKCS11 interface and the Java Cryptography Extension, or JCE interface. And unlike KMS, it lets you export keys. And it's billed by the hour per module with no free tier at all. That single-tenant, sole custody nature is the whole reason CloudHSM exists. Here's the mental picture. KMS is a high-security shared bank vault. It's professionally guarded and extremely well protected, but you're sharing the building with other tenants, separated by logical walls. CloudHSM is you renting your own private, physically separate vault where you hold the only keys and Amazon Web Services itself can't enter. You get stronger isolation, but you pay for and operate the whole building yourself. And here's the part that trips up people who learned this a few years ago. The FIPS level is no longer what separates them. Single tenancy is? Let's bust an outdated assumption directly. For years, the story was that you needed CloudHSM to get FIPS level 3. That's no longer true. KMS achieved FIPS 143 level 3 validation as well. So if a scenario simply says FIPS level 3, KMS now qualifies on its own. The word level 3 by itself no longer forces you to CloudHSM. What forces you there is a requirement for dedicated single-tenant hardware under your sole custody. So when does Amazon Web Services itself say to reach for CloudHSM? Their guidance is precise. Use it only if your compliance regulations require a single-tenant, FIPS Level 3 hardware module under your control, or if you need the PKCS11 or JCE interfaces. That's the whole trigger, a regulation mandating sole custody, or a hard requirement for those programmatic interfaces. Absent those, KMS wins on operational overhead every single time. And the cost gap makes the default obvious. A customer-managed KMS key runs about $1 a month. A single CloudHSM runs about $1.60 an hour, which works out to roughly $1,170 a month running around the clock. And because Amazon Web Services recommends running at least 2 for high availability, your realistic baseline is closer to $2,300 a month. That's a difference of about 1,000-fold. When the numbers are that lopsided, you don't pay for a private vault unless a regulation is explicitly holding a gun to your architecture. There's a middle ground option worth knowing. What if a scenario demands single-tenant hardware and native KMS integration across Amazon Web Services services? For that, there's the KMS custom key store. It keeps the actual key material inside a CloudHSM cluster, while KMS provides the familiar service integration on top. You get the convenience of KMS with the isolation of CloudHSM. The one limitation to remember is that it works for symmetric encryption keys only. When a question asks for both dedicated hardware and broad service integration, the custom key store is your answer. Everything so far has been about data at rest, but encryption has a second half, data in transit. That's where ACM, the Amazon Web Services Certificate Manager, comes in. KMS protects data sitting in storage, while ACM protects data moving over the wire. It provisions and, crucially, auto-renews your public and private TLS certificates. Think of it like a passport service that quietly renews your passport before it expires and slips the new one into your wallet, so you're never stranded at the border. When used with the Elastic Load Balancer, CloudFront, or a PI gateway, those public certificates are free. There's one behavior worth knowing. Historically, ACM private keys were non-exportable, so you couldn't install a cert on a raw EC2 instance. That changed in June of 2025. Public certificates issued on or after that date can now be exported and installed on EC2 containers and on-premises hosts. Certificates issued before then stay non-exportable. The decision rule is simple. If you need to terminate TLS on your own compute, use an exportable certificate issued after that date. Otherwise, let managed services like the load balancer terminate TLS for you. Here's a regional quirk that catches a lot of people. If you're serving HTTPS to viewers through CloudFront, the certificate must be requested in the East 1 region, North Virginia, no matter where your origin actually lives. But for a load balancer, it's the opposite instinct. That certificate must be in the same region as the load balancer itself. CloudFront viewer certs go in East 1. Load balancer certs go in the balancer's own region. Commit that split to memory. Let's put the two halves side by side. On the left, encryption at rest with KMS. It's envelope encryption of stored data across S3, EBS, RDS, and more, with key control and CloudTrail audit using customer-managed keys by default. On the right, encryption in transit with a CM. It handles TLS termination at the edge on the load balancer, CloudFront, and a PI gateway with free auto-renewing certificates. The key idea is that these two are complements, not alternatives. A complete design uses both, KMS to protect the data where it sits, a CM to protect it while it moves. Let's carry the decision rules forward. Envelope encryption is the model. A data key encrypts your data, and KMS encrypts the data key, which is what lets it scale past that 4 kilobyte limit. Default to KMS customer-managed keys whenever you need control, rotation, or audit. Remember, the KMS key policy is a separate gate, so IAM access alone can still be denied. Reach for CloudHSM only when a mandate genuinely requires single-tenant sole custody hardware. And a CM covers encryption in transit, with CloudFront viewer certs living in US East 1. Now let's see how well all of that stuck with a quick 5-question quiz. Question 1. A company must encrypt terabyte-scale objects in S3 with KMS, but KMS can only directly encrypt small payloads. How does it protect these large objects? Option A, it uses envelope encryption, where KMS generates a data key that encrypts the object locally, and KMS encrypts that data key. Option B, it streams the entire object to KMS, which encrypts it in chunks. Option C, it stores the object unencrypted and encrypts only the bucket policy. Or option D, it splits the object into 4 kilobyte blocks and sends each one to KMS. Pause here if you want more time. The answer is A. KMS caps direct encryption at 4 kilobytes, so it uses envelope encryption. A locally generated data key does the bulk work on your object, and KMS only ever encrypts that small data key. The large data never travels to KMS. Question 2. An engineer's IAM policy explicitly allows KMS decrypt, but the request to a customer-managed key still returns access denied. What's the most likely cause? Option A, the IAM policy also needs S3 dead object. Option B, the KMS key policy doesn't grant the principal access and doesn't delegate to IAM. Option C, KMS keys can't be used by IAM users, only roles. Or option D, the key is in a different availability zone. Lock in your answer before I give it away. The right call here is B. The key policy is a separate authorization date. Unless it grants the principal directly or includes the enable IAM user permission statement that delegates to IAM, your IAM permission alone gets you nowhere. 2 doors, and both must say yes. Question 3. A defense contract requires cryptographic keys held in dedicated single-tenant hardware under the customer's sole custody, with no other tenants sharing the module. Which service satisfies this? Option A, an Amazon Web Services managed KMS key. Option B, Amazon Web Services Certificate Manager with a private certificate authority. Option C, Amazon Web Services CloudHSM providing a single-tenant dedicated hardware module. Or option D, a customer-managed KMS key with automatic rotation. Think about which constraint matters most here. It has to be C, and here's why. The words single-tenant, dedicated hardware, and sole custody are the exact trigger for CloudHSM. KMS is multi-tenant, so even though it's now FIPS 143, level 3, it can't satisfy a single-tenant sole custody mandate. Question 4. A team imported their own key material into a KMS key and wants it to rotate on a schedule with 0 manual effort. What do you tell them? Option A, enable automatic rotation. It works just like Amazon Web Services generated keys. Option B, imported keys rotate every 90 days by default. Option C, they must migrate to CloudHSM to get rotation at all. Or option D, automatic rotation isn't available for imported material, so it can only be rotated manually or on demand. Got your pick? Let's see. If you said D, well done. Because Amazon Web Services doesn't control imported material, automatic rotation is permanently off the table for it. You can rotate it manually or on demand, but never on an automatic schedule. Question 5. You need a public TLS certificate from ACM for a CloudFront distribution. Where must that certificate be requested or imported? Option A, in the same region as your CloudFront origin bucket. Option B, in any region, because CloudFront replicates certificates globally. Option C, in the US East, North Virginia region, Who's East 1? Or option D, in every region where CloudFront has an edge location, think about which constraint matters most here. It has to be C, and here's why. CloudFront only reads ACN certificates from us East 1, no matter where your origin or your viewers sit. Request the cert anywhere else, and it simply won't appear as an option for the distribution. This regional quirk catches people constantly. And that closes out encryption and key management, KMS and CloudHSM. If it made the topic click, do me a favor and subscribe. It's what tells YouTube these lessons are worth showing to other learners. Tell me in the comments what stuck and what didn't. If there's a cert you're chasing that I haven't built yet, request it below. That list shapes what I make next. And honest notes on the pace or the visuals are always welcome. Until next time.